Section 7.4 talks about integration of further trigonometric functions. So here we make use of the Pythagorean identities. You need to be able to remember that sine squared plus cosine squared equal 1, and more importantly, sine squared is 1 minus cosine squared, and cosine squared is 1 minus sine squared. Always, also you need to know about 2 and 3. So if I remember that sine squared plus cosine squared equal 1, if I divide each of those by sine squared over sine squared is 1, cosine squared over sine squared is cotangent, and 1 over sine is cosecant. And if I go back to this again, Pythagorean identity, and divide everything by cosine squared, sine squared over cosine squared is tangent squared, cosine squared over cosine squared is 1, and 1 over cosine squared is secant squared. Now, so this is going to come up a lot more than you like. You should really remember that. This, the middle, is nothing more than a bridge to 7 and 8. This doesn't come up as much. This does. But you could use a u sub instead of remembering this. We know the sine of 2 theta is 2 times the sine of theta cosine of theta. So if I decided to solve for sine of theta times cosine of theta, divide both sides by 2. This is very quick to integrate, no need a u sub. Cosine of 2 theta has 3 identities. I want the last 2. Notice, if I solve this for cosine squared, I will get this identity. Move the 1 to the other side and divide by 2, there it is. And if I take the sine squared, solve for sine squared, I'll get number 7. So I really need to know 1, 2, 3, 7, and 8. 5 you could get around, but the rest you can't. So we break this section into 2 components. First component deals with sine and cosine. The second will deal with tangent and secant, or cotangent and cosecant. So let's get that out of the way. If I see sine or cosine, I'm trying to see if one of them is odd. So, sine to the n, cosine to the n. If n or m, either one of those is odd, then save a factor of the odd function. If it's the sine that's odd, save a sine. If it's a cosine that's odd, save a cosine. That's your du. And use number 1 right there. If n and m, if both of those happen to be even, then you would use 7 or 8, depending whether you have the sine or the cosine. So to start off my first example, I want to do both of those odd, then a combination of those, even and odd, and then go for evens. So I start off with the first example. If I want to integrate the cosine cubed, well, if it's odd, what you do, you save a factor, meaning take a cosine of x out, and wouldn't that leave you with cosine squared of x? Keep in mind what you're doing. Every time they say save, this is really your du. And then what? Then use 1. What does 1 say? 1 says sine squared plus cosine squared equal 1. So if this is my du, what does cosine squared equal by 1? Isn't cosine squared 1 minus sine squared? So now what? Well, if what I'm going to save will always be my du, can you guess what u equal? If I let u equal the sine of x, isn't du the cosine of x dx? So this is my u. Okay, it didn't change colors. This is my u. And there's my du. And what would this be? Wouldn't this be u minus u cubed divided by 3 plus c? What's u? U is my sine, so that will be sine of x minus, either you say sine cubed of x over 3 or 1/3 sine cubed of x. And there it is. So a nice trick you really need to get out of the way. Something that's not gonna go away. It'll keep on coming back over and over. When I look at part B, I'm seeing the sign. Again, if I see one of those being odd, according to the rule, what I do, I rewrite this. I save one factor. So I save the sine of x dx. That means, what do you multiply sine with to get sine cubed? The sine squared of x. And again, this is going to be my du. So I would say sine squared, according to number 1, is 1 minus the cosine squared of x. Kind of the same thing, with one minor exception. If this is my du, that's what I save all the time, then u will be what? What do you take a derivative of to get sine? Well, obviously the cosine. Du will be negative the sine of x dx. So there's my u. And there's my du. Off by a minus, we already know the drill. So this is the integral of negative du and a 1 minus u squared, identical to what we just did. That's negative u minus u cubed over 3 plus c. And I need to substitute u back. U was a cosine. If you could leave the negative up front, you could distribute it. It doesn't really matter. And there it is. It seems I could fit the third. I was trying not to squish things. Let me see if I could fit part C right there. If I could, that would be good. If not, it doesn't really matter. So if I was to put part C right there, I notice here I have sine and cosine, but it doesn't matter to me because I see there is a cosine raised to an odd power. If you see a combination, a sine or cosine, if one of them is odd, save one of the odd factors. So this sine I'm going to leave alone. But this cosine, I'm going to save a cosine out of it and write that as a cosine squared of x. Remember, this is my du. What do you let u equal to get a cosine? You let u equal the sine. So this sine is fine. But this cosine I need to get rid of. I know what cosine equal. That's 1 minus sine squared of u. Cosine of x dx. I'm sorry, I'm so stuck on u. Now what? Now I know if I let u equal the sine of x, du is the cosine of x dx. Let's see how this plays. U is going to replace two of these functions. Du is right there. So this is an integral of u squared into 1 minus u squared du. Now, if I really look at this, wouldn't this be u squared minus u to the 4th? Wouldn't that be u cubed over 3 minus u to the 5th power over 5 plus c? And if I substitute what u equals, wouldn't that be the sine cubed of x over 3 minus the sine to the 5th of x over 5 plus c? And there it is. Let me arrange the others. Okay, I did arrange them. How about this? Again, I'm looking at this problem and I notice, hey, one of those is odd. Now I notice this is the cosine, the sine and cosine of 3x. I know what the price is. I'm gonna pick a 1/3 at the end when I finish the integration. If you can just remember that or start from the beginning with that, you're okay. If not, no big deal. We'll have to make 2 substitutions, which makes this a bit longer, but that's okay. We can do that. So, again, the fact that this is a 3 tells me that, you know what? If I let u equal 3x, du will be 3dx. I'm going to pick a 1/3. If I can remember at the end to write 1/3 times whatever I get out of that integral, I don't have to worry about the 3x. I could just use x. And if I'm not sure, no big deal. Let w equal 3x. dw is 3dx. That means this right here is 1/3 with a dw, and this now becomes the sine to the 5th of w, the cosine squared of w. So the reason I say maybe you should just write the 1/3 there, as it is, the length of these problems is going to start expanding. They're going to get longer and longer, and you want to save as many steps as possible. So if you could start thinking that way, you save yourself some work. Now that I have it in terms of not 3x, a w, I could pay attention to the rule. I see an odd right there. I'm going to save one of these factors. I'm going to save the sine of w dw. That means this cosine I'm not going to touch. But if I take the sine to the 5th and I save a sine of it, doesn't that mean there's sine to the 4th of w left? And now what? Now I do know how this works. I know that I take a derivative of cosine to get the sine. So this cosine is fine. I need to get rid of that. But that's not a squared. That is to the 4th. Can't I say that is the sine squared of w, quantity squared, or the cosine sine squared times sine squared? And can't I say this is 1/3 the integral? Now if I use my Pythagorean identity, what does sine squared equal? Isn't that 1 minus cosine squared of w? Now I'm not saying this is short. This is a long problem, but it's not that hard if you follow the steps and work slowly. So I notice that this is 1/3 the integral if I let u equal the tradition. If I let u equal what? If this is my du, what do you take a derivative of to get the sine? Well, obviously, the cosine. If this is my du, oh, I'm so stuck on x, I mean w. Du will be negative the sine of w dw. So the blue is right there. I'm off by a negative. I can fix that. So a negative and a du. Now, if I let u equal cosine, I need to write this slowly. That's 1 minus u squared, and there's another u squared there. Now I know how to do this. That's negative 1/3 the integral of. This is 1 minus twice u squared plus u to the 4th times u squared du. That is negative 1/3 times the integral of u squared minus 2u to the 4th plus u to the 6th du. I'm going to raise this just a bit. I need a bit more space, couple of steps. So I'm going to raise this higher and say, look, follow the work right there. This is going to be negative 1/3, and wouldn't that be u cubed over 3 minus 2? Isn't that u to the 5th over 5? Isn't that u to the 7 over 7 plus c? And what's u? U was the cosine of w. And what's w? W was 3x. Wouldn't that make us the cosine of w, which is 3x? And there is my final answer. So, lengthy problem, but that's how it works. And there it is. Now, what if I'm looking at part E? Actually, part E turns out to be a bit nicer than you think. The catch, you must use 7 or 8. 7 or 8 meaning you have an even, you don't have any odd. Well, if it's sine, you use 7. If it's 8, you use cosine. Since it's sine, you're going to use 7. So sine squared of an angle is 1 minus the cosine of twice the angle divided by 2. The only way to do this problem would be to use that. There's no other way around it. That is the integral of, this is 1 minus the cosine, and how does it work? The cosine of what? Whatever this angle is, you double it. That's the key. Whatever this angle is, you double it. If you double 5x, isn't that 10x? Wouldn't that be 1/2 the integral of 1 minus the cosine of 10x dx? Isn't that 1/2? What do you take a derivative of to get 1x? And how about that? Isn't that the sine of 10x? What do you do with the 10? You divide by it. Otherwise, you would have to use a u substitution again, make the problem longer. Alright. And this is a special problem. They do come up. We have applications that match those. So this one is going to be lengthy. If I don't see an odd and I only see an even, the only way to do the problem is to make this the sine squared of x squared, or the sine squared of x times the sine squared of x. No way around it. And the only way to get rid of that is to really say sine squared is 1 minus the cosine of 2x divided by 2, quantity squared, or times 1 minus the cosine of 2x divided by 2. Lengthy problem, bear with it. And wouldn't you say this is 1/4 the integral? And if I FOIL this, 1 minus twice the cosine of 2x plus the cosine squared of 2x dx. That is 1/4 times. What do you take a derivative of to get 1? That's an x minus twice. What do you take a derivative of to get cosine? That's the sine of 2x. What do you do with that 2? If you take a derivative, you would multiply. Since you take an antiderivative, you divide. Plus the integral of the cosine squared of 2x dx. That's what I meant when you see a 4. You have to do it twice. That is 1/4 x minus 1/4 the sine of 2x plus 1/4. And how does that work? There's only one way I could work an even power. Use 7 or 8. Since it's a cosine, I'm going to use 8, which says it's 1 plus the cosine of twice the angle divided by 2. This is 1 plus the cosine of twice that angle. What's 2 times 2x? 4x divided by 2. There is no other way of doing this problem. So few problems, you will have few options. This is not one of them. That's going to be 1/8 times what? What do you take a derivative of to get 1? That is x. What do you take a derivative of to get the cosine? Sine of 4x. If you take a derivative, you multiply by 4. If you take an antiderivative, you divide by 4. On a test, this is what I want. For the homework, you would notice this is 1/4 x plus 1/8 x over 8, 2 plus 1, 3/8 x minus 1/4 the sine of 2x plus 1 over 32 the sine to the 4 of x plus. This is half of this section. We're going to stop here for you to master the sine and cosine before we go on. So, you're going to get half of this section for this homework, and we'll finish the other half in the next video.